This is Algebra 2, Chapter 3, Section 1, Part B, in which we are still solving systems of equations. If you recall, last time we worked on the graphing method, where we graphed the two lines and found where they intersect. There's two other main methods that we can use. One of these methods is called the substitution method, and the other is called the elimination method. Some books call this the add-subtract method, but I'll call it elimination. The substitution method is the first one we're going to look at today. The goal here is to get one equation to where you have one variable solved. So you're going to have two equations with two variables, typically x and y again. Your goal is to get one of those variables alone in one equation. Then you're going to substitute what you find into the other equation. This will make more sense when you see a problem in use. This is stuff you have done before. You did this in Algebra 1. This is just kind of review more than anything. So then you'll have an equation that's just one variable to solve. Solve it, and then substitute that value back into the other equation, or either equation, to finish it. Like I say, explaining it in words is kind of tricky. It sounds like I'm saying the same thing over and over again. We substitute here, we solve this, we substitute something else. But when we do it, you'll see that, oh yeah, this is something we did before. We did this in Algebra 1. And it will make more sense to you. So we're going to solve this system using the substitution method. Now I'm looking at my two equations. And there's one equation that is set up nicely to be able to use substitution with. 2x plus y equals 7. If I solve this equation and get y by itself, all I have to do is subtract the 2x over. Okay? I don't need to divide by anything. So, question that's always asked, how do I know which one to work with? Work with the one that you won't have to divide. If you tried to work with this top equation, you're going to have to divide by a 5 or divide by a -3, and you're going to have fractions all over the place. And I know how well you love fractions. This one, I don't have any fractions to deal with. So I'm going to take this equation and subtract the 2x over. So I find out that y is equal to 7 minus 2x. Now, I've got a value for y. It's this expression, 7 minus 2x. So I'm going to take that and substitute it into the top equation. So I'm going to take y out of here and put 7 minus 2x in its place. That's what substitution is. You plug that in. Notice I plugged it into the equation I didn't start with. If I plugged this back into the equation we used here, we would get 7 is equal to 7, which tells us exactly nothing. So we need to substitute it into the other equation up here. Now we know how to solve this. We're going to distribute our -3. -3 times 7 is -21. -3 times -2 is a +6. Collect up our terms. So we have 11x here, and then I went ahead and added the 21 at the same time. So I divide, and I find out that x equals 4. Halfway home, I've got one of the two variables solved. Now I take this x equals 4, and I'm going to plug it back in over here. I could plug it into one of these at the top, but since this one is already set up, I'm going to plug in here. So y equals 7 minus 2 times 4. Excusing our dear Aunt Sally, we get 7 minus 8, so we have -1 for y. And then finally we report what the solution is. Just like we did on the graphing, we have to name it as a point. So we need to say the solution is 4, -1. Okay. You're still finding a point, you're just not doing it graphically. You're doing it algebraically. I ask you to pause here and try to solve this one out using your substitution method, and hopefully it jumps right out at you which equation to start from. So pause here, give it a shot, see what happens. Okay. Hopefully when you started this problem you saw the x was already without a number, it had nothing to divide by, so that's the one I want to start from. Bring the 7y over. Take that 7y and 7y plus 11 and plug it in where x is. Distribute. Collect up and divide, and we get -2. Substitute the -2 in. 7 times -2 is -14, plus 11 is -3. So we say the solution is -3, 2. The other method that we're going to study today is called the elimination method. And the idea is we want to be able to eliminate a variable from discussion. To do this, we have to sometimes multiply one equation or sometimes both equations by something so that we have equal and opposite terms to collect together. And I'll show you what that means in a minute. Again, this is just review. You've done this before. Then when you add the two equations together, you eliminate a variable. Now you're able to get down and solve for x or y, whichever, and then substitute that back in and solve again. This is the method that most people like the best because it's the fastest. So we're going to solve this one with the elimination method. I have an option. I can pick on x and try to make these opposite of each other, or I can pick on y and try to make these opposite. I'm going to choose to pick on y. So I want to make both of these numbers the same. If I multiply the top row by 3, I get a 6y. If I multiply this row by 2, I get a -6y. See how these are now opposite and equal terms. +6y and -6y. That's what I want. Had I picked on x, I would have to multiply by like a 4 here to make 12x, and a -3 to make this -12x. Okay. I want to make them the same number but opposite. Now when I add these things together, 9x plus 8x is 17x. The y's cancel out. 3 plus 14 is 17, so we get the answer x equals 1. Now I can take this number and plug it in to either one of these equations. Doesn't look to me like one is any better than the other, so I just pick the top one. X is 1, so 3 times 1 plus 2y equals 1. 3 times 1 is 3. Subtract the 3 and then divide. And as before, we're going to name our solution as a point. 1, -1. Just like we did with graphing, just like we did with substitution, we're looking for a point. We're just not necessarily graphing it, but we're still looking for a point. Okay. So I'll ask you to pause here and try this one. We're looking to do elimination this time. So pause, give it a shot, come back and check your answer. So I chose to pick on y again. Could have picked on x, it wouldn't have mattered, but I chose y. So I multiplied the top row by a -2 to make -4x, -6y, and still 0. And I multiplied the bottom one by 3, 9x plus 6y equals 15, so that my y's will cancel out. 5x equals 15, so x equals 3. Take my 3, plug it back in. I picked the top one again. 6 plus 3y equals 0, so we work that down, y equals -2, and we reported our solution. Now, last thing we have to deal with is sometimes we get strange results. If we work these things out and we end up with a statement that is clearly true, 0 is equal to 0, or 5 is equal to 5, or something where it's obviously a true statement, then this would be like the case we did with graphing, where it's consistent and dependent. And another term they like to use is that you could say that this has infinitely many solutions. That's when you get a true statement. If you get a clearly false statement, you get a complete lie. 0 equals 4, something that's obviously not true, then what you're dealing with is parallel lines. And we said that would mean inconsistent. You could also say that there's no solution. Thought so. So we did the substitution method, we did the elimination method. Most of your problems are going to work out where you get a solution. Occasionally you get these two oddball cases, so make sure you're on top of those and what they mean. As always, if you had questions, I hope you brought those in, wrote those down, bring them in with you, and we will see you in class.